With this video, I will show you how to find chemical information and literature using SciFinder. To access SciFinder, you can go to the Databases link, or you can go through one of the chemistry research guides like CHEM 306A. From the CHEM 306A online guide, if we select the Articles tab, on the right side you'll see the SciFinder icon and the SciFinder link. If you click either one of these, followed by the SciFinder login URL. Now remember that you will need to access SciFinder through the CSUF username password, followed by the SciFinder username password that you created from the last video. Okay, so this is the SciFinder interface. At the top we have the tabs, and you can search all the information for substances only, information for reactions, the literature search for references, and suppliers. If I click on the Substances tab, here you can type in the name of your substance. Once you start typing your substance, a drop-down menu will appear and you can select the substance of interest. So I'm selecting morphine. You can also combine your search with different operators using different parameters here, from molecular formula or to different thermal properties. So you can combine the keyword with actual numerical values. I'm just going to use morphine, and I'm going to click on the search button. Now you can see that the database has retrieved morphine and other substances too that contain the keyword morphine. If I make this a little bigger, now you will notice that each substance has a number at the top. This number is the Chemical Abstracts Service Registry Number. It's the CAS number. The CAS number is a unique identifier of a substance. It's very much reminiscent to that of your Social Security number. One person, one Social Security number, one substance, one CAS number. Below the CAS number, you will be able to see the chemical structure of your substance. If you hover your mouse over the substance, right-click, and then select Save Image As, you can save the image on your desktop. I'm going to label it as morphine. Once you saved your image on your desktop, you can then transfer it onto your Word document. So that's the chemical structure of morphine. I want to add the CAS number as well. And there's the CAS number, and this is for the first part of the exercise. You need the CAS number, you need the chemical structure of the substance. Okay, if I go back, now below the chemical structure you see the molecular formula followed by the name of your substance. Then you see three icons: references, reactions, and suppliers. If you click on the references icon, here you'll see all the references associated with morphine. There are over 67,000 references from SciFinder that deal with morphine. So these are different document types. On the left side, you can filter the document types by journal, patent, review paper, etc. You can also refine your set of over 67,000 documents by substance role, by language, by publication year. So if I click on View Larger, I can see that the publication years from all the documents go to the 1800s all the way to this year. So let me just move it a little forward. It is kind of interesting. It has, as you can see, that the growth of number of articles has increased over time. So I'm going, let's see, over the last couple years. Over the last 5 years, for instance. Click on the Apply button. And now I have narrowed down my set to just over 6,000 results, 6,000 documents, with the publication years from 2019 to this year. I can narrow it down further by document type, say journal. Now I have 5,600 results. I can exclude different parameters as well. Okay, so if I go back, so this was back to my substance morphine, and I just looked over the references. If you click on the reactions icon, the database will retrieve all reactions dealing with morphine, and there are 1,636 results. Again, on the left side, you can filter your result set, or you can exclude your result set. You can filter or exclude by different parameters. For instance, if I select product, this now has filtered all the reactions where the substance is as the product. So this is essentially the synthesis of the substance. And I have other parameters that I can filter by: the yield of reaction, number of steps, different groups, reaction scale, reaction type, reagent, catalyst, and so on. Now, each one of these reactions, if you click on Expand Scheme, it will give you more information about the reaction, including the literature, these are the articles or patents dealing with that reaction. If I go back, so I've looked at references, reactions. If I click on suppliers, this will give me different suppliers where I can purchase my substance. This is the name of the supplier, followed by the name of the substance. These are all morphine. The purity of the substance, some information about purchasing details, and availability. It sometimes even gives me the actual cost for the different substances. Okay, so let's go back. The last thing I just want to mention is that if you click on the CAS number, this will bring up more information about your substance. Here you can see again the chemical structure, the molecular formula, the name of your substance, and with this database, this first bit here, goes at the end. So it's 7, 8, dihydro, etc. And this bit goes at the end. This is the IUPAC name. If I scroll down a wee bit more, this table gives me more information about the substance, other names and identifiers. It also gives me experimental properties. So if I click on the downward arrow, I get information about experimental properties associated with the substance. And there are different tabs that deal with the different property information. For instance, if I click on thermal, these are all the different melting points that have been reported for that substance. And each value here has a source. So this is where the value has been reported. So under the source 1, this document has reported it as 255 degrees Celsius. Whereas this one here, document 7, 242 to 244 degrees Celsius, can be found by clicking on document 7, and so on. The reason there are different melting points reported could be because of how the melting point was conducted. Maybe it was under higher pressures, or whether they used a specific solvent, or whether the actual material was actually pure. Maybe there are different isomers, or how the melting point was read by the student or the researcher, etc. So there are different reasons why the melting point could be different. Okay, if I scroll down a wee bit, so these are experimental properties. You also have experimental spectra. If I click on the downward arrow here, this table provides the different spectra associated with your substance. You have the NMR, the carbon-13, the IR, mass spec, Raman, UV visible, and there's sometimes more spectra as well. And again, they are different sources that show where the actual spectra has been reported. And under the sources heading, you can actually go to the actual document. Sometimes you can view the spectra. So if you click on the first link, View IR Absorption Spectrum, this downloads the actual IR for that substance. At the top here, you can download the whole IR here on your laptops or computers. You can email it to yourselves. And notice with this IR, there's a really broad peak here. I can see around 3000 to 3500 wave number. Obviously, this is due to the OH stretch. Okay, if I go back, so I've talked about experimental properties, I've talked about experimental spectra, and then there's other table parts to this. There's the predicted properties, predicted spectra, and so forth. Okay, so let's go back. The next thing I'd like to talk about is how do you find the article for your assignment. There are a number of ways you can find an article from SciFinder. You can click on the references and then pick an article from there. You can also go back to SciFinder, this is, you can see that we search under substances, but you can also do reaction searches by typing the name of your substance here. If you click on references, this is where the database searches for the literature on a keyword or keywords. So here I can select, maybe type in morphine, or I can go to this search box and refine my search by different parameters here, like the title. For instance, I'll be searching for morphine and synthesis. So I want these keywords to appear in the titles of all the documents. Click on the search button, and here you'll see the results of 949 documents that contain the terms morphine and synthesis in the titles. On the left side, I'm going to select journal, so I want to refine it to journal articles. And now I have 727 results. If I experiment with the publication year, click on View Larger, and then select my indicator here to the last, say, couple years. Click on Apply. I think this is the last 5 years. I have now 27 results. On the left side, notice you can refine by other parameters, by author, organization, publication name, different CA concepts, as well as database. So when SciFinder searches, it searches for chemical abstract plus database, as well as Medline. So it retrieves results from these two resources simultaneously. Pretty powerful. Now in the center, you have your documents. These are all articles. Okay, so for the assignment, you need to find an article that deals with the chemical or biochemical information about your substance. Okay, this one deals with synthesis of morphine, so I'm going to pick this one. So at the top you have the title, which is linked, followed by the names of the authors, the name of the journal, Nature Communications, the year, the volume, the issue number, and the page numbers. Below the document, you can click on View Abstract, so that gives you an abstract and some chemical information. You'll also see below each document or record the full text. You can access the full text from the CSUF library catalog, from the DOI number. Now the DOI number stands for Digital Object Identifier. It's a unique identifier of a document, one DOI number. And sometimes if you click on this, it links it directly to the full text. You also have View All Sources, so you can see where the document is available from different sources. On the right side, you'll see a button for substances. So there are 109 substances that's talked about in this document. There's 518 reactions. Citing, that refers to the number of researchers that are actually citing this specific document. And you can often get more information about the research from this article in other articles from the researchers that are citing it. There's also a citation map. So if I click on that, the citation map provides a visual representation of the documents that are citing it and the documents that have been referenced from their specific document. If I make this a little smaller so you can see, so this document has referenced 51 different documents, and 43 documents on the other hand have been citing this document. If you place your cursor over each one of these, it gives you information about the documents that are citing it, or information that has been referenced. If I click on one of these and select Expand Citations, it will expand the documents that are citing this specific document, so you can get more information. Remember that when the references that are citing, or the documents that are citing the specific document, you are now going forward in time compared to the documents that are referenced from this document. Here you're going back in time. Okay, so let's go back. Now if I click on the title of a document which is linked, I will go to the document record. This is where the database has found the keywords and the parameters that I've originally placed in my search strategy. You can see the abstract in the center. Okay, it's gone back. There you go. You can see the abstract in the center, and on the left side you have some information about the source, the name of the journal, volume, issue, page number, as well as the publication year and the DOI number. If I scroll down a wee bit, you have more information about the concepts, the database where this information was found, substances. If I click on the downward arrow for cited documents, you get access to all the documents that I've been citing this specific document. Okay, so if I go back, and if I want to find the full text, I'll click on the full text button, select Find it at CSUF, and this will go to our library catalog, and it will tell you if we have the full text available. And as you can see, the full text is available from all these different resources. This could be publishers' sites or different resources, databases, etc. At the top I can see a Get PDF link, so I can just click on that to get the full text. And here you'll have the actual document, the full text. The article here starts off with the title of the document, followed by the names of the authors. Then you have the abstract. The abstract is a short paragraph that highlights the key results and outcomes of the study. If I scroll down a wee bit, here you'll see the introduction and background information about the research. Then I'll see the results. There's some reaction schemes here, some more tables and data. Then there's a discussion section. Then after the discussion, I notice there's a methodology or method section, sometimes labeled as experimental. And this sometimes goes right after the introduction, but here they've placed it at the end of the article. And then you have references. Okay, so if I save this document as a PDF, Okay, so see if I can get the PDF and put it to the front screen. So this is the PDF of the article. Now for the assignment, you will need to find an article for each one of your substances. Once you found the article, you need to highlight the name of the substance wherever it appears throughout the article. You can do that by getting a highlighter and manually highlighting the actual substance. You can also highlight it online. If you've downloaded the Adobe Creative Cloud, it will allow more functionality and flexibility with the actual PDF. So here I have the PDF of the document, and at the top here there's a Tools tab. If I click on that, I can select the Redact icon here and just click on Add and go to my PDF. Okay, I don't see anything yet. Let's go back and just try it one more time. Click on the Redact icon, and there you have it. You'll see the two icons appear here: the Redact Text and Images and Sanitize Document. Under the Redact Text and Images, if you click on the downward arrow, and if you click on Properties, a pop-up will appear, and at the bottom here you can select the outer line color of the box for redaction. So it will search for the keyword and it will create a box that will encapsulate the keyword within the document. So if I clicked on that, the colors will appear, and you can select whichever color you want for the border outline of the box. I'm just going to leave it as purple. Now for fill-in color, you can select that as well. Let's try to make it kind of a yellowish. And you can select the opacity of the actual color. You don't want it to be something like 100% or towards 100% because you won't be able to see the key word. Let's go something for about 18%. Let's make it up. I say 20%. Click OK. So the outline is going to be purple and the highlight will be a yellowish color. Once you've selected that, you go back to the Redact Text and Images, click on the downward arrow, click on Find Text and Redact, click OK, and here you can just type in the keyword that you want to be redacted. That means highlighted. So I'm going to type in morphine. Whole words also case sensitive. That's okay. And it's already found the keyword wherever it appeared throughout the actual document. Let's check all. And then at the bottom here, mark checked results for reduction. Let's see if it works. There you have it. That's the outside color of purple, and the inside color kind of a yellowish color. Looks like it's worked pretty well. So just print this out and you're done for this part. Okay, so let's now go back to SciFinder. Let's just move this out of the way. Close this. And finally, for your search strategy, at the bottom here, let's go back to the actual SciFinder. So I just clicked on CAS, and here you have your recent search history, and you can use your search history to show them your search strategy. There's a number of ways you can do this actually. So let's just click on the edit search and just cut and paste this. That's your search strategy for finding the article, morphine synthesis. Let's go. See if I can just cut this, and that will save it on your desktop. Okay folks, well that's pretty much it. Thank you for listening.